Hello world. Today we're going to be taking a look at 30-day lead coding challenge on LeetCode, and we're going to look at the first problem of the first week to celebrate this great event. So I've not seen this question yet, so hopefully I can figure this out in a reasonable amount of time. Let's see here. Move this to the side. A single number given a non-empty array of integers, every element appears twice except for one. Find that single one. And our goal is to achieve a linear runtime complexity and without using extra memory. So I'm just going to break down the problem. So given non-empty array of only integers, each int appears twice except one. Find that element. We have two examples. It's pretty nice of them to give us. So the array 2, 2, and 1 returns 1 because 1 is the integer in that collection that has a count of 1. Let's check out the next one. 4, 1, 2, 1, 2. And that returns 4 because just like the first example, 4 has a count of 1, just like 1 did. So I know I'm going to have to loop through this collection. Thinking of how to do this without extra memory, so like without a hash table to keep track of the counts, and also keeping it linear. So linear just means we cannot, the speed of this algorithm should be equal to the length of the array. So it shouldn't go over the entire, at most it should go over the entire array. So I've got an idea of what I can do with this. If I sorted, okay, so let's say our data structure is a sorted array, and we're looping over that. If we sort the array, so I'll just write it in here. If we sort that first one, 1, 2, and 2, we can see that 1 has a count of 1 by looking at it, but when the array gets huge, say like 30,000 elements, we won't be able to tell that easily, especially when they're all out of order. But if we sort it, we can see it a lot easier, and we can predict what the array will look like as we go through it. So it's going to return 1, of course. But basically, as I go through the array, I think I could do, basically, if you look at the current element, which is 1, that's our first element in the loop. If we look at the previous element, it's undefined. And if we look at the next element, it is 2. So we can see with these two pieces of data that 1 is the only one in the array. And since we know that there's only one element in the entire array that appears once, we can assume that that first one is the number to return. Let's see if this mini algo holds up for the second example. So we're returning 4. Let's sort that into 1, 2, 2, the other one, 2, 2, 4. So we'll also return 4. So first iteration is 1, previous undefined, next is 1, so pass. Oh, got rid of everything. Second is 1, previous is 1, next is 2, so pass. Third, 2, previous is 1, next is 2, pass, fourth, number 2 again, previous is 2, next is 4, pass, and last, we've got 4, previous is 2, and the next is undefined, return 4. So basically the qualifications for the number being the correct one to return is that previous is undefined or not the same as current integer, and next is undefined or not the same as current integer. So this is our first algorithm. We'll see if this works. It might not. I'm not sure if they're going to let sorting happen in this question, because they already said they only want to have a linear time complexity. I'm not sure if sorting is going to get in the way of that. Trying to think if I need to prep anything else before I start coding. Let's switch this to ES6. So basically all I need in terms of extra memory, all I need is the actual array and then one counter. So let's sort the array. Sort AB, we're going to sort this ascending order. Let's make sure that that is correct. Oh, need to subtract. Okay, that's good. Now we're going to do a for loop. Let I equals 0, I is less than num's length, and we're incrementing I in each turn of this. Yeah, actually, I might want to increment I on my own, because I'm going to need to, I might need to increment on my own. I'll leave it automatic for now, but I might need to switch that. So let's put a little comment there. Possibly remove I plus 1. So basically, let's put in that case where we know we can return if nums I minus 0 is undefined, or nums 0 is not equal to nums I, which is the current element, and I'm going to put parentheses around this just so I can keep track of it a little better. I'm going to export this to a function. But for now, I'll just leave it as is. Or if the next element, which is I plus 1, I minus 1, and not 0. That wouldn't be right. So the next one is undefined, or nums I plus 1 is not equal to nums I. Then we know we can return nums I. Now I'm thinking if I left anything out. Let's put a return here. Also, I'll just run the code and see what happens. Okay, we got the right one. Let's add the other test case. 4, 1, 2, 1, 2. Good expected answer. Let's see if we put in a test case with 3, is that 12? That'll be our answer. 4, 4, 6, 6, 8, 8, 8, 4, 44. Let's just see how that works. It says expected answer would be 4 for that one, which is interesting because it should be 12. Oh, every one appears twice. Maybe that's messing with it. Okay, yeah, that was a problem with that test case. So at worst, this solution solves it in linear time because we either end it at the last element or we end it anywhere before that. In terms of extra memory, I think we're doing pretty good on that. Let me just throw in one more test case. It seems pretty straightforward, though. I did not input that correctly again. So I got back 54, which isn't even one of the answers. Okay, 33, that's correct. 1, 4, 12, 33. It works for the 4 test cases we have. It's expected behavior. The edge cases, the question pretty much eliminates a lot of the edge cases, like an empty array or an array where there's actually an element that appears 3 times or 2 elements appear once. So I'm going to go ahead and run this and just see if it works. Okay, it works. Let's check out the details, see if it gives us the runtime. 80 milliseconds, that's pretty good. Beats 25% of JavaScript submissions. That's not bad. Let me run it again, see if we get a little better runtime on that. Now it's taking forever. Okay, now we're at the actual page. Let's see. That's it. Yeah, 25%. Oh, these questions are repeated. Okay, these aren't original questions. I did this a long time ago in Ruby. Okay, I didn't remember it. 25%. Not bad. Thanks for watching. Hope you learned something new. Probably not, because it's a pretty simple question, but it's probably going to get harder near day 15 or day 20, maybe even day 3. So hope you check back in again. Have a good day.